So I'm back to my default settings on the GAIA here, and we're going to look at the oscillator section. Again, we're kind of moving from the end to the beginning, and we've been using a sawtooth waveform the whole time so far, but now is a good time to bring up kind of other waveform types and also kind of get into pulse width modulation and this other type of envelope they have here in the oscillator section. So we have many different waveforms in this, and there's more than actually meets the eye. We can click wave and cycle through a bunch of waveforms, and at this point I think it's really helpful to switch your viewer over to wave view so that you're seeing the waveforms as you play them, right? It's also nice to get the kind of idea that as we choose different pitches, we're actually kind of scrunching the waveform and spreading it out, right? Frequency is the number of times per second, right? How frequent something is happening. And we can see that really clearly on our waveform viewer. If I play a low C, we see kind of, 3 waves. If I play a high C above that, we're going to have twice as many, right? So kind of when we get to the oscillator, it's really important to start thinking about frequency and pitch, and that if you go up an octave, you're doubling the frequency, or doubling how many times per second the wave is happening. Now let's go through these waveforms. For each one of these waveforms, we have a series of variations on it. So if I'm in the sawtooth waveform, we see that's what it looks like. If I hit variation, we're going to get a slightly different version of it, and we have 3 different versions of every one of these. I can click over to my rectangular square wave, and we have 3 different versions of that. I can go to my pulse width modulation wave, and we have a couple different versions of that, and I guess you can kind of go through and see kind of what's going on there. Now, one thing I like to kind of point out at this point is to get a waveform that looks good, like we have a square wave there, and then start filtering it with a low pass filter here. So let's see, I'll play a C here, and I'll start filtering it. And we're going to see how this changes the waveform and actually makes it look very much like a sine wave, right? So we're finding that the wave shape, or the shape of the waveform, is directly related to the upper harmonics, right? And as we start removing the upper harmonics with a filter, it starts looking more and more like a sine wave and starts sounding more and more like a sine wave. And we also notice that if you look at that wave, it's a bit more triangular shaped than a sine wave actually is. So if I bring my cutoff frequency all the way up and switch over to my sine wave, we have a nice smooth sine wave, and we find, we got those great waves, we find that a sawtooth wave, we find that a triangle waveform really sounds like a filtered square wave, right? They both have mostly odd harmonics, and we can start talking about the different waveforms that we have there. Works great, but it's really important as you're going through these and working with these with your students to really think about what variation you are on, right? It's not just a matter of which waveform, but also the variation, because they can sound very different from each other. So that's a really important thing to know. And it goes from clear to red to green and back to clear. Now, built into this oscillator, we have a coarse and fine tune pitch. The pitch here is going to move by half steps. And detune moves by 50 cents in either direction, right? So it's going to give you like a quarter tone out as you bring that all the way down and then go up. You'll also find that adjusting detune is very smooth, but working with pitch is very coarse. We get these kind of discrete jumps as we're moving the pitch knob there. Now, one of the fun things to start playing with the oscillator section is the built-in envelope. And this is a different type of envelope. So it's another really common one that we see. It's really just the first 2 stages of an ADSR envelope. So we had ADSR in these, attack, decay, sustain, release, in both our amplitude, amplifier, and filter section. And in the oscillator section, we just have attack and decay. And one sound that I really like to make with here is just a kick drum, right? Like a big 808 style kick. If I switch over to the sine wave, right, we play, we'll get that just sine wave sound, and then I can start manipulating my envelope to get kind of a nice punchy kick. If I go down an octave maybe, we get a nice low tone, maybe right there. I can bring up my envelope depth, and then start working with decay time. And we get those kind of standard dance kick sounds out of this. And then, I often bring up, well, okay, this sounds good. I get that nice kind of punch at the beginning, gets down to a nice solid tone, but what else needs to change? And what needs to change is it's a kick drum. It would have a percussive envelope, not a sustaining one, right? So then we had to think also about our amplifier section, go back to the amplifier envelope, and really think about making it a percussive envelope. And now we have like a nice kick drum sound and really working with the amplifier envelope. So we find that it's very similar to working with the filter envelope, and that we have the envelope depth that can be both positive and negative. But every time you're building a sound, it's now we have to coordinate all of these filters and all of these sections together to get that sound to be perfect. We can also make a bunch of different just effects out of this, right? Like I could bring up attack. And get those kind of funny, all those you find if you start playing with this a lot, you get all the kind of cool, chiptune kind of Nintendo sounds out of it. These are kind of fun to play with. Some great special effects. So this is really nice for the effects. Also, just the really slow glides can be nice if you are on a sustaining envelope. So those big kind of riser sounds. And I like this one because you can see in the waveform display as it's slowly rising up, because my attack time is high and my envelope decay and my envelope depth is high, we see that as we go up, we scrunch up the waveform there, right? So higher frequency means more times per second. So this really brings in the ideas of kind of what is sound and how is it functioning, right? We can see it just get higher and higher like that. Now, the last thing I like to look at in the oscillator section is pulse width modulation, or just pulse width in general, because it's kind of a weird term. What does that mean? And we have this great visualizer, so it's wonderful to kind of explore it with this view up here. So let's switch over to the third waveform, which is the pulse width waveform. And as we do, I'm going to bring my envelope depth down to the middle, which is going to be 0 envelope depth, and my attack time all the way down, just so I'm back more at that kind of default starting point, and I'll play the sound. And we get this square wave looking sound. I can choose the variations. I like the third one just because it looks so squarish. I don't know. And then we can start working with this PW fader here. Now we have two faders that deal with pulse width modulation. The one that's PW is a manual pulse width modulation. I can do that with a fader here. And the blue one is related to the LFO, which we'll look at in a future video. So let's see what pulse width modulation is doing and get a sense for what it sounds like. If I play a note and move this, we see that it's actually changing the duty cycle, which is another word for this, right? We're saying, okay, how much time is it in the positive direction and how much time is it in the negative direction? And as I manipulate this, we get that variation between the two. As we get up to be a pulse width like that, it's a very nasally sound. Often that's kind of used as the basis for like vocal synthesis, if you have some bandpass filters. Or I can get kind of a more bassy sound out of it when it's like that. And that in motion is quite nice. And that's actually putting it in motion is what the PWM, or pulse width modulation, fader is for, which we'll look at in a future lesson. Now, when working with the oscillator, it's also nice to look at the idea of mono and portamento. So far we've been making sounds that you can play more than one note at a time. They've been polyphonic patches. I can play a chord, and I get a chord, right? Notes overlap. But if I put it in mono mode, we can only play one note at a time. Right? Even if I'm playing multiple notes, we're only going to get one note at a time, which works quite well. Now, one of the great sounds, and what we hear all the time in acoustic instruments, is that, like even a violin, even though it has 4 strings, we tend most of the time only to play one note at a time. And once we're doing that, there's all these great ways we can kind of transition between those notes. Sometimes I'll glide between them, and sometimes I'll just jump discretely between them. And we call that gliding portamento. And it's a common feature in synthesizers as well. And we need to be able to control the speed of that portamento and when that portamento happens. So if I turn on portamento, and actually you'll see this flash as I did that. If I hold it down, we have these which we were using for arpeggiator before. These are flashing. We see 3 flashing. That means it's going to be a pretty quick glide. If I go up here, it'll be a slow glide, right? So we're actually changing portamento time by holding the portamento button down and clicking the various numbers. Let's leave this pretty high and see what happens when I play now. If I play, we see that it glides between those notes with portamento on. If I turn portamento off, it doesn't glide, right? And I can Portamento time quick, and it glides quick, right? We can kind of control that, you know, have the speed of that Portamento. Great feature, and that's right where it is in the GAIA here. So I'm going to put this back in polyphonic mode, and I think that's all I want to talk about for the oscillator section. And now we're going to look at the LFO.